Last year, automobiles caused over 38,000 deaths in the U.S., and we spent over 8 billion hours sitting in traffic. Vision Zero is a plan to prevent collisions and improve traffic flow. In August, Department of Transportation tests concluded GPS is not accurate or reliable enough for smart cities, indicating the need for alternative positioning. To address this, 5D deployed their Universal Positioning Node in shark fins and street infrastructure in a large area of Manhattan. In 2 hours, the New York City Department of Transportation maintenance crews installed the UPN on 10 city blocks, enabling a smart city where everything operates smoothly and safely. "5D is working with progressive cities, smart lighting, and automotive companies to accelerate adoption of connected and autonomous vehicles around the world."
And smart cities, essentially. So this demo contains various use cases we have realized together with our partners, Coda Wireless, Siemens for the infrastructure side, of course the city of Austin, and so the first thing we're about to see is that on that screen right in front of you, I hope you can see that we get information from a traffic light. So we're right now standing in front of a red traffic light. That traffic light transmits that information to the car, so we can see it on our screen. And it tells us that we need to spend another 30 seconds until it goes green. So the idea here really is to make traffic lights more intelligent, smarten up, and get the information from all the different cars approaching the crossing. And once the traffic light gets all that information, of course, you can imagine that you can switch much more intelligently, much more optimal in order to steer traffic, and by that essentially reduce traffic jams and traffic in general, and make it able for you to reach your destination much faster in time. So the technology we're using here is called V2X. So that is essentially an automotive Wi-Fi standard. It's 802.11p, and the beauty about this technology is that you can connect cars with each other, cars with the infrastructure, like we've just seen on the red light, on the traffic light, peer-to-peer. There's no server in between, there's no cloud in between. It goes really peer-to-peer, which provides us with information with very low latency. So as soon as, for instance, in safety critical situations, somebody brakes in front of you, you will get that information in that very second. Imagine your car is driving autonomously, it will brake immediately. That's very relevant, for instance, for platooning use cases. So imagine truck platoons driving in a train of trucks. The first truck brakes, the very last one in that chain of truck will get that information within maximum 250 milliseconds. So there's no risk of bumping into the car in front of him. So we now get even information on the traffic light around the corner, which we don't see. And that's another beauty about V2X. It sees around corners or through walls. And it's now actually green. We get the information it's green where we don't see. Now we can also visually confirm that it's green, so our system is working here. And the traffic light or the car tells us now that we should at least drive 9 miles in order to catch that green phase. So Chris, we need to make sure that we drive fast enough so that we can cross that street. So these two use cases on the traffic light, in principle, show use cases on V2I. So the communication between
autonomous vehicles will not be widely adopted. Most autonomy solutions today rely on GPS, but GPS lacks accuracy and doesn't work indoors, underground, or in the canyons of large cities. Vision systems help, but struggle in featureless or dynamic environments and are easily disrupted by dust, rain, snow, and foliage. The 5D positioning and navigation node solves these shortcomings. The 5D node integrates sophisticated positioning and behavior technology that includes a patented fusion of GPS, inertial sensing, optics and laser-based localization, plus innovative ultra-wideband ranging. The combination of these navigation methods results in greater tracking precision and reliability over large areas. By attaching 5D nodes to a combination of humans, ground, and air vehicles, the 5D nodes behavior engine offers two main modes of autonomous behavior. When connected in a peer-to-peer fashion, the virtual tether mode allows humans and equipment to maintain relative positioning for follow behaviors. Drones can be linked to ground vehicles to provide critical aerial data. Automated takeoff, tethered flight, and landing drastically simplifies the data collection process. Ground vehicles can carry heavy loads while following. Vehicles can even be chained to create intelligent convoys. It takes only a few hours to affix nodes to existing infrastructure to create a 5D constellation in order to establish absolute positioning in any environment, indoor or out. With Virtual Rail, users can easily and instantly define and modify paths for vehicles to reliably follow with no cost to reconfigure. In all situations, vehicles featuring the 5D behavior engine are completely aware of dynamic elements in their environments. Built-in guarded motion and obstacle avoidance behaviors provide reliable autonomous operations and greater safety for all. The 5D node is a small, rugged, plug-and-play device that can be easily integrated into a variety of applications. Autonomous shuttles, personal automated mobility, vehicle convoys, autonomous forklifts and scissor lifts, autonomous drones, service and logistics vehicles, (3D) mapping and surveying. 5D helps assess, plan, test, and deploy effective solutions that make it cheaper and quicker for organizations of all kinds to realize the benefit of autonomy. As more and more industries adopt 5D technology, smarter, more connected ecosystems become possible, where people are more productive, operations are more efficient, and workplaces are safer. Contact 5D today to bring the benefits of reliable autonomy to the vehicles in your business.